All right, in this video, we are going to continue our discussion on similarity in right triangle standard number 8, which is basically trigonometry. Solve trigonometry problems. And this was the bell ringer that we had in class, and we ran over it. Basically, if you're not sure about this, go check video 1 for this standard. Our work today builds on this. In particular, we noted yesterday that when we were solving these problems, we had a technique. We started by looking at the problem and then searched were we given opposite, adjacent, or hypotenuse. For this problem, we were given opposite and hypotenuse. Opposite and hypotenuse were used to build sine. So basically, we looked at the problem, figured out which pieces we were given, took those pieces to build the equation, and solved it. Our work today follows the same structure. We have to look at a problem and determine which pieces were given. Are we given opposite, adjacent, or hypotenuse? Once we figure out the pieces we have, we will build an equation and solve it. The big difference, though, between yesterday and today, in our work today, we don't know the size of the angle. And so we're going to figure out how big the angle is, whereas yesterday we were figuring out how long a side was. Building the equation won't be any different, but the steps we need to do to solve it will be a little bit. Before we get to that point, I want to check to see that we can use a calculator. Determine the value of theta. Round your answer to the nearest tenth of a degree. Now, before we look at this particular thing, I'd like to remind you of some stuff that you've seen in the past. We've had problems like this in your earlier classes. What do you do to solve? You'd subtract. Because you know adding and subtracting are inverses. They cancel each other out, allowing you to get your answer. You've also seen a lot of problems like here. And so you saw to get rid of multiplication, you'd use its inverse of division. Multiplying and dividing cancel each other out, allowing you to get the answer. You have also seen problems that looked like this in your earlier classes. What do you do to solve it? You'd take the square root, because we know squares and square roots are inverses. They cancel each other out, allowing you to get to your answer. A very common theme in math are having functions and their inverses that cancel each other out. When you get to Algebra 2, you will look at a type of function called exponents and logarithms. Exponents and logarithms in your future class are going to cancel each other out, and you learn how to do those. Well, for us, we have sine, and we want to say, how do you cancel out a sine? It's based on a notation that you had back in Algebra 1. Do you remember from Algebra 1 that we had a function, and there was also a part where you searched for the function's inverse? This little -1 notation is how we write out inverse. And it's the exact same thing that we are going to do today. We are going to use the inverse of the sine function. And so it's no different than using adding and subtracting to cancel, multiplying and dividing cancel, squares and square roots cancel, sines and sine inverse cancel. Please get out your calculators and note, if we check out the buttons on our calculator, we know right here at the sine button, well, look right above it in the blue. If you look above it in the blue, using my second key to access it, you see how it says sine inverse? This is what's used to cancel. If you want to cancel out sine, we have to use inverse sine. If we want to cancel out cosine, we will use inverse cosine. And likewise, to cancel tangent, we'll use inverse tangent, and they're located in the blue directly above what we have. So let's solve this equation. What do you have to do to get theta by itself? Take the inverse sine on both sides, of course. Sine and inverse sine will cancel each other out, and we're left with theta equals exactly what we need to type into our calculator. So we'll take this and say inverse sine of 0.4256. Please notice my calculator is set to degrees, so I don't have to worry about changing it off of radians. And we have our answer, 25.2. Rounding it to one decimal place, we have 25.2 degrees. This is the primary tool we will use for solving in our work today. I'd like to run through and check a couple other things. Let's solve this one. Okay, since we have cosine, we know we'll cancel out cosine with inverse cosine. Those cancel, giving us theta equals the inverse cosine of 0.8523. And the students in class are telling me that after they put that in their calculator, it rounds to 31.5 degrees. We're done. Please notice what this is telling us then. This is telling us if we take the cosine of 31.5 degrees, it'll give us this 0.8523. So they've got the back and forth relationship. We see that inverse cosine of 0.8523 gives us the 31.5 degree angle. But we'll also notice if we take the cosine of 31.5, what should it give us? Yeah, it should give us what we had before. Rounded, of course, because we are having these answers that get rounded on us. And big surprise, it matches up. 8526, a little bit off from the 8523, and it was, of course, because we rounded the angle. If we took a cosine of a more accurate rounding, say 3154, if we're more accurate with our rounding when we go backwards, we'll see it gets closer. So we know because of rounding, we're going to wind up with pieces that are a little bit off. We're accepting that small error, not a problem for us. Last one with your calculator. In order to solve it, I'm noting a lot of people in class aren't even bothering to write it down. They're running straight to their calculator, recognizing that we have to take the inverse tangent, giving us theta is equal to 53.6 degrees. So using the calculator for inverse sine, inverse cosine, inverse tangent, we're good. If you wind up going on to the internet, and this is the part that I'm just going to warn you about, if you go check the internet for some of these pieces for inverse trig functions, you will sometimes encounter this. Or you can find something on the internet that says arc sine, arc cosine, or arc tangent. That's just a different name for this stuff. Arc sine means the exact same thing as sine inverse. There's no difference whatsoever. It just, you know how we have different ways of writing multiplication? Well, there are different ways of writing inverse trig functions. If you go searching for them, don't be surprised if they pop up. In class, I'm going to restrict ourselves to using these. This is the notation we choose to use because it matches what's on our calculators. But if you go searching elsewhere, don't be surprised if you run into this. Okay, so let's solve this problem. Find the value of this angle theta. Well, we'll start the exact same way we did before. Based on our angle, which pieces do we have? Are we given opposite, adjacent, or hypotenuse? Okay, what is the 14? 14 is adjacent, and 7.7 is opposite. Based on having opposite and adjacent, that tells us it builds tangent. Tangent of what? It's tangent of the angle theta. Tangent of theta is equal to opposite over adjacent. And you notice how similar this is to what we were just doing with the calculator? How do you get theta by itself? How do you get rid of tangent? We'll take inverse tangent. After taking tangent and inverse tangent, we have then theta is equal to tangent inverse 7.7 divided by 14. And let's put that into our calculators. Inverse tangent of opposite over adjacent gives us our angle. Rounding it to 1 decimal place, we have a 28.8 degree angle. And we're done. I would like to make one other comment here. We will do some more examples of these coming up, but please don't think that there's anything special about theta. This theta is just a dummy variable. It represents the angle. We don't care what symbol we're using. Our work would have been absolutely the same if we instead said tangent of angle B. If we're using the letter B for the angle, well, our work doesn't change at all. There's nothing important about this letter theta. There's nothing important about the letter B. We could have used a question mark. We could have used a smiley face. Use whatever symbol you want. The symbol is not important. The important thing to keep in mind, if you're trying to figure out an angle, you will use an inverse trig function. Inverse trig functions give you the angles. So now let's do this one. I'd like you to complete it on your marker boards. Okay, running through the solution. Based on our angle, we have to look at the two pieces we're given. 11 is the hypotenuse. Of course, we recognize that because it's opposite the side of the 90. You can also recognize that 4.4 is the adjacent side length. Since we have hypotenuse and adjacent, those are the pieces that are used to build cosine. Cosine of theta equals adjacent over hypotenuse. In order to solve it, we'd have to take the inverse cosine and after taking the inverse cosine, we get precisely what we need to type into the calculator. And after doing that, several of the students pointed out to me, this gives us 66.4 degrees. Let's do our last example for this particular video. Just verifying a question that was asked in class. Theta is referring to the small angle A. They didn't want to write theta too small simply because then you wouldn't be able to see it too well. Looking at this particular problem, we would have to recognize 4 is one of the pieces we're interested in, as is 13. 4 is opposite of angle theta, and 13 is adjacent to angle theta. So which one do we build? Using opposite and adjacent, that's exactly what tangent is. So we have tangent of theta equals opposite over adjacent. So to solve this one, we know we'll have to take inverse tangent. And after those cancel out, inverse tangent of 4 over 13 leads us to a 17.1 degree angle. And we're finished. It doesn't matter if we're using sine or cosine or tangent. The amount of work it takes to solve is always the same. Just keep in mind the process we're using. Look at the triangle and determine which pieces you have. Depending on if you are given opposite, adjacent, or hypotenuse, you will build an appropriate equation using sine, cosine, or tangent. After you've built the equation, we'll solve it. And those provide us our examples. Continue in our work in similarity in right triangle standard number 8, using trigonometry to figure out stuff about right triangles.